So hi and welcome to our first SmartInspect webinar. My name is Marcus Grau from Faro Product Management. In this webinar we will give you a short overview how the software works. The presenter today is one of our application engineers, Darren Cran from the UK, to who I will hand over now.
Thank you, Marcus. Hello everyone, and thank you for joining our webinar. My name is Darren Cran, and over the next 30 minutes I'll introduce you to a new dimension of measurement, CAM2 SmartInspect. I'll start with a short introduction to SmartInspect Basic, giving an overview of the user interface and showing some of the basic features. We'll then move into SmartInspect Pro, looking at the user interface, and then into live demonstrations of some of the key features, showing that once complex routines are now as easy as a click. Should you have any questions, please make a note of these, as we'll have a question and answer session at the end. You can use a chat to ask any question, and please send these to the host and presenter. So, if everyone's ready, let's begin. Okay, so here you can see SmartInspect Basic. Most of you will recognize this as CAM2 Gauge. However, additional functions have been added. The user interface has several tabs that offer many functions. We have the Home tab, which contains file management commands, as well as settings and preferences for the software and hardware. The toolbar at the top contains the Measurement tab, which contains all the features that we can measure with the Faro arm. We have a Construct tab, which contains the options for creating angles, lengths, GD&T, as well as theoretical features that we can construct from a combination of existing features. We then have the Tools tab, which contains short macros that have been created combining measurement and construct commands to enable quick and easy calculations for angles, lengths, geometry, and GD&T. The first two options here allow the user to create and manage their own tools. The My Tools tab will allow quick access to any user-created tools that have been created from the toolbar. So, continuing across, we have the Measure Mode tab here. This enables the Faro arm to be used when issuing a measure command. We then have the Edit mode, which switches SmartInspect into an offline mode, which enables the user to create an inspection plan without having a Faro arm attached. We then have the Report Manager. Using the report configuration, we can choose what features to report on, but also what properties of that feature to report on. We have the Tool Settings, which allows us to export files to CSV for SPC. We can choose the report template, and we can choose to automatically print, etc. We have a report editor, which allows the user to customize the header as well as the layout of the report. And we have a print preview option here to see the report. Continuing across the top, we have the 3D caliper. This allows us to use SmartInspect as a three-dimensional caliper or height gauge to quickly check dimensions relative to 1, 2, or 3 measured planes. And finally on the top, the Help key. This opens up the software help files. Okay, now over to the left-hand side of the screen. Here we have the World tab. When we click this, this opens up the Coordinate System Creator, which allows us to create coordinate system using different types of features. Below the World, we have the feature list, which will display the features as the user creates or measures them. To the bottom of this panel, we have the Start menu. This allows us to remeasure the inspection plan from the beginning for batch inspection. At the foot, we have the Quick Preferences. If we open this, this is where the user can choose the coordinate system type. So we can choose Cartesian, spherical, or cylindrical. We can also select the unit format here, either millimeters or inches. And where there's a need to compensate for temperature for the material and for the component, the user can also select the material from here and can also manually enter the temperature of the material from here. Where a Faro temperature probe is attached, the temperature will be calculated automatically every 5 minutes and used within this window. The temperature window here will become read-only. Moving to the right, we have the status bar here. In here we will see the serial number of the arm, its status, is it connected or disconnected. We'll also see the last calibration date and time of the probe. And we can choose the measurement mode from here, from single point to either distance interval scan mode and choose a dimension between each point, or we have a time interval and a time between each point. Okay, if we now move across into the large panel here, this is what we know as the image viewer. This will display a basic image of the feature type, and it will show green balls which show the minimum number of points to be taken, but also the position, as well as the red ball which displays where to compensate. In this window we also have the option to replace the basic image by using the small buttons to the top left of this window. We can either capture an image from a webcam, or we can load an image from our laptop. So in this case, if I load the image, we have a select picture menu, I click the green plus, I browse to the location where the image is, and we choose the image. This imports into the software. I then simply select the image, and that now replaces the basic image. Once the image is imported, we have other options available within the side menu. Using the green dot, we can simply click on the component to determine where the user must probe, and also the number of points. We can then use the red to detail where to compensate. The slide bar below the points will increase or decrease the size of the points. We then have a pan where we can simply move around, and we can also zoom in using the roller ball on the mouse. So if we now measure the feature, the image will guide us through the measurement. So right click and we measure. Okay, once a feature is measured, we can see the results of that feature, the properties, by clicking the slide bar here. This will reveal the properties, where we can change the name of the feature from here. We can tag the features as datum here. We can see the actual result column here, which the arm has captured. We also have a normal column where we can enter the data from drawing. And we have a tolerance column where we can edit the tolerances. Okay, so if we return back to the image. Okay, I'll just measure a couple of more features, and then we'll show you the coordinate system creator. So if I simply measure a 2D line, selecting from the top bar. And then a circle. Okay, so to create a coordinate system, we simply click the World tab. This opens a coordinate system creator. We then choose the features we have. So in this case, we have a plain line circle. So simply click the button. This opens up the creator. So here we can choose the plane, for example, the top plane. We can then choose the direction of the axis direction that comes from that plane. We can then choose the line at the bottom. And again, we can choose the axis. And we can choose the origin, in this case, circle 1. We can also rotate and offset the coordinate system via the options menu here. If we press the reset button, this deletes the coordinate system. To return to the image, we just click the coordinate system at the top. Okay. As a majority of you are familiar with CAM2 Gauge, I'll now move on to SmartInspect Pro. We switch between Basic and Pro via the preferences in the Home menu. We go to the Home menu, we choose Preferences. Under the General options, we have Application Layout Mode. We now switch this from Image to 3D. Software will reboot and restart when I click OK. Okay. Now we can see SmartInspect Pro. As you can see, there's now a 3D viewer in place of the image viewer. We also have a new menu bar in this viewer, which I will cover in a moment. You can see that the majority of the user interface is the same as SmartInspect Basic. Okay, I'll now move on to the live demonstration to show the workflow and features of SmartInspect Pro. Okay, so just to introduce you, during this demonstration, I'll use the Faro demonstration part. I'll measure plane 1, which is the top plane. I'll measure the center circle, the 100 mm datum circle, and I'll measure the front edge, or line 1. I'll then show how a coordinate system is created to be positioned as shown on the diagram in front of you. Okay, I could measure the features now, as before, from the top. But this is an ideal opportunity to demonstrate the auto recognition feature to you. So simply start probing the feature. And the auto recognize feature is activated. And it will offer me the best fit feature depending on the position and number of points I take. To accept, I simply compensate. And now the 3D viewer aligns to that plane. Should the auto feature get it wrong, it will offer you other features within the window, which I'll show you in a moment. Okay, I can now show you some of the functions of the sidebar menu. In here we have the zoom menu, so we can zoom in, zoom out. We can reset the view, which will reset to 3D. Clicking on a plane will align the view to that plane. Like so. Okay. We then have the camera menu, which has some preset views. So from the X direction, the Y direction, and the Z direction. We also have the 4 basic isometric views. Okay. We then have the panning mode, which allows us to move the image left, right, up, down. The cursor keys will also do this. We have the label menu, where we can switch labels on. We can switch labels off. We can show a simple label, which is the name only. Then we can show a detail label, which then will show us the results. We now have the feature properties panel, where we can see some of the information from the panel, where we can change the name. We can choose as datum, We can turn on or off individual labels for the feature here, and we can also hide the feature from visibility. We then have the readings panel, the bottom right here. This displays the individual points that have been taken to calculate this feature. By unticking a feature and clicking apply, that point will be removed from the feature and recalculated. We then have the feature information panel, which when open, this will show the results of the measurement. So we have the actual. We have a nominal, where again we can enter drawing values. And we have a tolerance column, which allow us to change the tolerances to suit drawing. To the right of this box, we have small tick boxes, which when selected, this will add that feature to the report, but also to the label, as you can see here. To hide any of the panels, we simply click the tab again. Okay, so I'll now continue and measure the line and circle. Again, I'll use auto feature recognition. So this is our line. Maybe our plane, sorry about that. Try again. That's better. And our circle. Okay, so here you can see SmartInspect is the auto feature recognition has chosen the wrong feature automatically, but you can see in the top window here we have a circle, so I simply click and that now changes it. And I just compensate accept. Okay, so to create the coordinate system, again, I could do it via the world as before, and we have the same options as we did in basic. But this is an ideal opportunity to demonstrate a great new function within SmartInspect, the workflow suggestions. So once we have features measured or created within the feature tree, we now see a light bulb below the side panel. If we click this, we now get suggestions from the software for the next step. So as I want to create a coordinate system, I simply hover over the icon to choose the one I want. So in this case, plain line circle, and it's as easy as click, and your coordinate system is created, and your view is now aligned 2D to that coordinate system. If you want to rotate back to a 3D view, hold the left mouse button, and we simply rotate. Right mouse button will allow us to pan. The I is a shortcut key in. O, shortcut key out. And again, selecting the feature will automatically rotate to the plane that feature is on. Okay, so SmartInspect adds a new dimension to measurement by actually prompting the user what to do next. I'll be using the workflow suggestions several times during the demo to show how easy the workflow becomes. Okay, so if we return back to the PowerPoint, the next step I would like to show is we will measure the 4 circles shown. Then I'll show you how to construct lengths. So we have 2 lengths to show you. And then I will show you how to create an angle using 3 circles. Okay, so I first measure the circles. Okay, so you can see very quickly that the labels hide in the graphics. So again, if we go into the label menu and hide all, if we want to zoom in, we can zoom in. Okay, once measured, simply select the required circles either from the feature tree here or from the screen. So in this case, we'll choose circle 2 and circle 4. And you will see SmartInspect has created a direct point length here automatically. If this is what we want, we select the line by just clicking on the line. It activates yellow. We can then simply drag the line to any position we want. If we wish to display the length, we can remove the lengths we do not want from the feature information bar. So simply we open the feature information and we untick the values we don't want. Okay, just to show you the next one, show how easy it is. This time I'll do it from the screen. So if I highlight the first circle, hold Control, highlight the next circle. There's our grey line. We click to select and simply we drag whichever way we want. So in this case, we want the dimension across X. And again, we can deselect the lengths we don't want. Okay, so now moving on to the 3-circle angle. Again, first of all, we select the two circles we want the angle between, and last of all, we select the apex. From the workflow suggestions, you can see here we get many options. So again, we hover over till we see the option we want. So in this case, it's apex. And again, it's as easy as click, and your angle is shown. Again, using the feature information here, we can enter normals, and we can enter tolerances, and you can see now the deviation is colorized depending on whether it is good or bad. Within tolerance, it will be green, and you will have a green tick. If it's out of tolerance, it will be red on the positive, blue on the negative. Now, I could have done all these constructions via the Construct tab, angles, etc. But hopefully you can see how the workflow suggestions have the ability to simplify the measurement process. Okay, I'll demonstrate a couple of more constructions using the workflow suggestions. So what we'll do next is we'll construct a PCD through the 4 measured circles. We'll then measure a cone and calculate the diameter of where the cone intersects with the plane. Okay, so again, I could go through the construct a circle best fit option here, but it's much easier to first select the circles I want. For the workflow suggestions, simply find the right option, and as easy as a click, we have the construction created. And again, from the feature information, we can enter our position and values. We can change the tolerances here if you wish. From the properties window on the right, we can choose to either show or hide the individual label. So I'll continue and I'll now measure the cone. So again, we'll use auto recognize feature. Switch off my labels. So now I need to construct the diameter here where it meets the plane here. So again, from the feature tree, I simply select the plane and then in the circle. And looking through my workflow suggestions, we have circle by intersect, as simple as a click. And there we have the intersection. And again, we can enter information here. Okay. So the next step, I want to demonstrate the GD&T functionality within the software. So in this case, I will measure the center cylinder as shown. I will then check its perpendicularity to the top face. So when using GD&T, I need to tag the relevant features of datum, using letters which are usually detailed within an engineering drawing or a blueprint. In this case, plane 1 is datum A. So I first click it in the feature tree. I then look in the properties, and I can tag datum, and then I can choose the relevant datum letter. In this case, plane A. You will see now in the feature tree, the plane is now tagged as datum A. Okay, so to check the perpendicularity of the cylinder, I first need to measure it. So again, if I measure the cylinder, I will just rotate so you can see it there. There we go. Okay, so now to check the perpendicularity, I simply go to Construct, GD&T, choose the symbol for perpendicularity here. Then on the right-hand side, top right-hand corner here, we have the properties for the calculation. I choose a feature to be checked, in this case cylinder 1. I then choose a datum. And here on the label, you see we now have the result, 6 microns. Okay, so hopefully you can see there the workflow suggestions is very helpful and really simplifies the workflow. Okay, so to finish off, I need to create a report, but before that I want to show you another new function, which is the whiskers and boundary. To do this, I'll now measure the smaller diameter here, which is on another plane. I will do this in scan mode, and I will show you how to activate the whiskers and then the form boundaries. Okay, so first of all, I measure the plane. You will see another function here. Because a new plane has been selected, SmartInspect automatically hides any other feature which isn't on that plane and aligns to the last measured plane. I now need to switch into scan mode. So if I now go to the bottom, to the device bar, I change the measurement mode from single point to distance interval. I can then choose a distance. In this case, I will do 0.5 millimeter. And then if I measure a circle, I can simply scan the probe holding the green button around the feature. So 268 points. Okay, so now in the properties panel of this feature, on the right here, we have the option to tick whiskers further down. So if we tick the whiskers, you can now see we have green lines which detail which side of the best fit circle the points are positioned. If I now tick the show tolerance bounds, this will show the tolerance bounds in blue depending upon the tolerance which is set within the feature information panel. So if we change the feature information panel to a smaller form tolerance, so here we have circularity of 18 microns. If we just change this, you can now see the boundary is reduced, and we can clearly see the areas where we are out of bounds here. Okay, so the last thing I need to show now is how to collate all this together in a report. So we simply click the report tab. This opens up the feature creator, the report creator. We have two boxes. We have the top box, which is features in report, and then we have a bottom box, which is features which are not on report. So we simply select by ticking or clicking the arrow to the left of the feature to add it to the report. We could also use the buttons here, the filters, add all in tolerance, out of tolerance, add all in tolerance, add all above tolerance, or you can do them individually. Just done. Okay, so again, to add to the report, we can select an individual feature, or we can multiply select, and then we can choose which properties of that feature to report on. So if we're not interested in 3D distance, we can remove it. If we're not interested in the Z value, we can remove it from the group. Okay. So moving down in the tool settings, we have the report template type. So we have a simple report, which will show, if I now click print view, preview, you will see a preview of that type of report. So here all we see is the actual and the nominal information. We go back to the report configurator. We can now change to tabular, which will give you a lot more information. So here we see the actual, the nominal, the deviation, and where we have entered nominals and tolerances, like here on circle 6, the deviation will be colorized depending on whether it's good, green, bad will be shown as red or blue. Okay, we have the report editor, which will allow us to customize the report. So very simply, we could change and we can change okay. To run a report, just to continue down the side, we have the set session information here, which allows us to prompt the user for the part number, the operator, etc. before the tool is run. At the end of the inspection plan, we can choose to automatically print to a printer, and we can choose this from the options. We can automatically choose to save the report in a set location. And we have two types, either PDF or XPS. Where the data is to be used for SPC software, we can export a CSV version by clicking here and choosing the location. To activate the report, to create the automatic save features, from the feature tree on the left, we right-click and we click Start Report. And as you can see, we now have to enter our information. So this will automatically create the report and save it in the locations I've shown. And the print preview, as you can see now, the session information has been updated. And we have our results. Okay, so that concludes my inspection plan. If I wish to run it again, I simply click the Start button at the bottom. This asks me, do I want to start from the beginning? Yes. And then I can continue to remeasure the features as prompted by the measurement window in the middle. Okay, I think you get the idea. Okay, so That concludes my presentation, so thank you very much for your attention. Now we'll move into the question and answers, and we're ready to go, so please, if you've used the chat to ask any questions, please do so now. Okay, we don't seem to have any questions yet. There's one question. Can we show the 3D view in the report? At the moment, no. This is maybe something we will develop in the future. Tracker. This is a question. Yes, the aim is for SmartInspect to work with arm, gauge, and laser tracker. At the moment, no, SmartInspect does not import or export CAD. Questions? Okay, we have one question from Leonardo Marquez. Can we export measurement as IGs? Unfortunately not at the moment. Having a few questions now. Can we import CAD? The answer in the current version is no. So if there's no more questions, thank you for your attention.